The last gas law is the ideal gas law, and there's the two equations, PV equals nRT. It's probably going to be easier to use this one though if you have mass. So if the problem gives you mass, use this one because it's got mass in it. And if the problem has moles in it, use this one. So we'll put moles. If you see moles or want moles, use that. If you see mass or want mass, use this one. And then just a reminder, the units for this one do matter. Pressure's got to be atmospheres, volume has to be liters, temperature has to be Kelvin. That's nothing new, but these two have to be what they are. Pressure's got to be atmospheres, volume's got to be liters because of this. Because the ideal gas law constant has this weird unit, atmospheres, liters, mole, Kelvin. So it's got to be atmospheres because of this, liters because of this, Kelvin because of this, and moles if you got moles. I'm not really going to focus on canceling out units with this one. So as long as your units are this, it's going to work out. So as you go through the problem, just underline what you know. So you're given 0.24 grams of helium. There's your pressure. If the desired volume of the balloon is 1.25 liters, what must the temperature be in degrees Celsius? So that's your question. So I see mass here, grams, so I'm going to use this version of the ideal gas law because it's got math in it. And I'm just going to start plugging in. Instead of cataloging, just to save space, I'm going to plug in what I know. So my pressure is 1.26 atmospheres. So 1.26 ATM. And then my volume, so V for volume, is 1.250 liters. And those are already what they have to be. Volume's got to be in liters, that's what it's in. Pressure's got to be in atmospheres, that's what it's in. So I'm fine plugging those in. If they weren't, so if this was like PSI or something, you would have to convert to atmospheres and then plug it in. We didn't have to because it was already in atmospheres. And then come back up. Mass, we know, is 0.2494 grams times the ideal gas constant, R, right there, 0.0821 atmospheres, liter, mole, Kelvin, times T. That's what we're trying to solve for, so we don't know what temperature is, so leave it blank. It says what must the temperature be, so we don't know. And that's over the molar mass. And it's the molar mass of whatever gas you have. So in this one, our gas is helium. So you got to go to the periodic table, look up the decimal, right? That's the molar mass. So mm for molar mass. The molar mass of helium, we're just going to use 4.0. So that is what we're going to put underneath. So molar mass of helium, 4.0. And now it's no different from any other one we've done. And you still want to cross multiply because you got a fraction. So cross multiply here. This doesn't have anything underneath, but you can say it's a 1 because that doesn't change anything, and it helps you cross multiply. So you're going to end up with the same thing, but that helps you see, okay, cross multiply. So you get 4 times this, so 4, and I'm going to drop the units now just to save some space. 4 times 1.26 times 1.250 equals 1 times this, which gives us the same thing. So we'll just do 0.2494 times 0.0821 times T. And now you got an easy thing to solve. So again, we cross multiplied, so we got 4 times this. That's where that 4 ended up over here. We put it over 1, so we could cross multiply here too. So you just get 1 times this. I'm not going to write the 1 because it gives you the same thing. So now just get rid of these to get T by itself. Divide by this. Divide by this. if we're going to do that over here, we got to do it over here. 0.2494 divided by 0.0821. And then that's t right there, 4 times, so multiply across the top, divide by the bottom. So when you do that, 4 times 1.26 times 1.25 divided by 0.2494 divided by 0.0821, you get 307. So you get t equals 307.7. And remember, it's Kelvin because all the gas laws are in Kelvin. They should be in Kelvin. If you solve them, they're in Kelvin. We want this in Celsius. So to turn this Kelvin into degrees Celsius, you just subtract your 273. So 307.7 minus 273. You get 34.7 degrees Celsius as your answer. Alright, so if you guys have any questions, email me, let me know. Reach out however you need to. And for homework on your own, you guys are going to try these bottom 2 ones. I know the numbers are messed up, so just ignore the numbers, but these next 2 right here. So they're numbered 6 and 8. So those are the 2 you guys are going to try on your own.